Earthquakes. Earthquakes are formed by plates sliding against each other. S and P waves make the plates slide against each other, making one go one way and the other going the other. The seismograph is what scientists use to measure an earthquake. They can show us the S waves or P waves and how big they are.
The National Earthquake Information Center in Colorado keeps track of every measurable tremor on Earth. Satellite dishes pick up data from seismographs around the world. Seismographs are instruments anchored to the ground to record the Earth's movements. During a quake, a needle suspended in the instrument makes a pattern of lines that tells how much shaking occurred. Waverly Person, who heads the Earthquake Information Center, watches these lines come in. Fast-moving primary, or P waves, arrive first.
See the P arrival here, P arrival here, P here. See all this in New Hampshire. There's a P there. This earthquake, I think, is not in the United States, but it's a pretty big quake. Probably, maybe south. This is just coming in. We don't even know where it is yet. This is an earthquake. This is the type of thing that just happened. We talk about prediction. We didn't predict this. We cannot predict. We cannot forecast. The earthquake is occurring.
Within minutes, a computer determines the precise location and magnitude of each quake. This information is sent to the pagers of others who follow up and check for damage. People have recorded earthquakes for centuries. A Chinese mathematician built the first seismoscope almost 2,000 years ago. A pendulum inside this device moves during a quake. This causes the balls in the dragon's mouths to spill into the frogs' mouths below. Measurements are a little more sophisticated these days. But even with modern technology, predicting a quake remains an elusive goal. Seismologist Lucy Jones explains.
Earthquakes are probably fundamentally unpredictable. And a key to seeing why that's true is to understand that we don't really want to predict earthquakes. There are 20 or 30 earthquakes every day somewhere in Southern California, just Southern California. What we're trying to do is not to predict earthquakes, but to predict which of the earthquakes we have are going to turn out to be large ones. To be able to do that, there would have to be something different in the way a big earthquake begins than in the way a small earthquake begins. And as far as we can tell, there isn't a difference.
To predict a quake, scientists need to recognize changes in the Earth that signal a quake's about to happen. They tried to position equipment in the right place at the right time to record the warning signs, but they haven't had much luck. History tells us where earthquakes are likely to happen, but just because a big quake is supposed to strike doesn't mean that it will.
Earthquakes can make buildings split, and they can also make bridges fall and streets crack, depending if the place is by the epicenter. An earthquake can be very effective, even if the place that it's around the epicenter is not in it. Earthquakes occur near plates between, for example, between the Caribbean and South America. A lot of earthquakes occur in California. Plates are between every single state or between every single country. These plates move against each other, and S and P waves make them slide against each other, and that's how an earthquake forms. Scientists use a Richter scale to find how big an earthquake is. There are 8 different earthquakes: micro, very minor, minor, light, moderate, strong, major, and great. These earthquakes go up from 1.0 and up to 6.0 and higher. The China earthquake was the biggest earthquake we ever knew. At least 2,400 people died. The China earthquake was made on July 28th, 1976, 4 o'clock a.m. The San Francisco earthquake The San Francisco earthquake was also a big quake. 700 to 3,000 people died. It occurred April 18, 1906 at 5:12 a.m. Some tips to survive an earthquake are to go in a cabinet or hide under a bed or a piece of furniture. You can also move away the plates in the ground, so you don't. If you don't have much furniture, grab a blanket or something to cover you up so that you don't get scratched with glass or anything else that's sharp.
Tornadoes are caused by warm air and cold air. Then the funnel cloud comes. Last, the updraft makes it touch the ground and the tornado is formed. A tornado can pick up a house and instantly disintegrate it. Tornadoes are called F0, F1, F2, F3, F4, F5, and F6 tornadoes. Tornadoes only form in Tornado Alley. Tornado Alley is a place where tornadoes form. These are some things in Tornado Alley. Kansas, Texas, Oklahoma, and Arkansas are all tornado states. A tornado happened in Joplin, Missouri. In the Joplin, Missouri tornado, 161 people died in the F5 tornado. Joplin, Missouri. In Joplin, Missouri, tornado. 161 people died in the F5 tornado. In Arkansas, in Fort Smith, in January 11, 15 p.m., 55 people were dead, and then 113 were injured. You can predict tornadoes because you can see the rotation when the tornado comes. To survive a tornado, you need to get to tornado shelter. Or you can hide in the closet or go under a piece of sturdy furniture, and you need a plan to survive it and an aid kit and food.
Earthquakes occur when two tectonic plates move suddenly against each other. The rocks usually break underground at the hypocenter in the earthquakes. Waves spread from the epicenter, the point on the surface above the hypocenter. If a quake occurs under sea, it can turn into a tsunami. An earthquake can cause a light feeling to massive destruction. The category goes from 1 to 10, and each one is 10 times stronger. And each category has a number of times that earthquake happens again. The destruction of the earthquake is rated by a Richter scale. A Richter scale is a numerical calculation with the number rising with severity of tremors. It has no upper limit and is based on a logarithmic. Damage increases tenfold with each whole number.
Several types of scales measure earthquake magnitude. Probably the most familiar, the Richter scale, measures the amplitude of the waves from the seismographic reading in millimeters and uses logarithms to convert the measurement into a number to represent the magnitude. To To compensate for the variations in distance between seismographs and the epicenter, adjustments must be included in the formula. Richter's distance correction factor is based on a separate, more complicated logarithmic equation, so for convenience we will tabulate these numbers in a chart. If an earthquake located 110 kilometers away has a seismographic reading with amplitude of 7 millimeters, what would the magnitude be? First, you will use a calculator to find the log of 7, which is 0.845. Then you would refer to Richter's chart for the distance correction factor and find that at 110 kilometers, the adjustment is negative 3.08. So the Richter magnitude is 3.9. An earthquake with magnitude 3.9 may be felt, but it rarely causes great damage. Suppose you are analyzing the seismographic reading of an earthquake whose epicenter is 450 kilometers away. If the amplitude of the waves measures 24 millimeters, what is the magnitude? After finding the log of 24, which is 1.38, you must subtract the distance correction factor. At 450 kilometers away, the adjustment is negative 4.62, which gives the earthquake a magnitude of 6.0. A magnitude 6.0 is a strong earthquake that can cause damage to buildings and other structures.
Along the coast of the oceanic and the continental plate and in the states, like California and Alaska and Oregon and San Andreas, and some are happening now. You might not just feel it because it's so small, but if you feel one, go somewhere safe.
In addition to the Salton Sea, another very interesting geographical feature of Southern California is the San Andreas Fault. That is because it marks the meeting point of two enormous pieces of the Earth's crust, known as tectonic plates. As can be seen here, the San Andreas Fault just looks like a huge crack in the ground. But it is an important landmark because the land to the west of the fault belongs to the Pacific Plate that forms most of the seafloor of the Pacific Ocean, while the land to the east of the San Andreas Fault belongs to the North American Plate that makes up most of the continent of North America. The tectonic plates of the Earth's crust move very slowly over a softer layer of rock 45 to 90 miles beneath the surface. Which is why the city of Los Angeles, which lies to the west of the San Andreas Fault, is creeping northward at the rate of more than 2 inches a year compared to the land on the eastern side of the fault. As the edges of the tectonic plates slide against one another, tremendous pressure builds up. An earthquake, a dangerous event in which the ground shakes violently, releases that pressure. That is what happened back in 1906 in the city of San Francisco, which lies right on the San Andreas Fault. During the San Francisco earthquake, the ground was actually ripped wide open, and most of that great city was destroyed. Since then, several powerful earthquakes have rocked California, but so far, none has been quite as destructive as the earthquake that struck San Francisco back in 1906.
The two earthquakes that happened in history was the 1906 earthquake in San Francisco that was really big and probably the biggest one yet. The earthquake in China that was big and killed 830,000 people.
There are 3 very different stories from China in the news this week. An earthquake struck a hard-to-reach area in southwestern Sichuan province. At least 41 people are reported to have died in the quake that caused considerable damage.
No, not even a scientist can predict the earthquake because it can happen at any time, and they tried, but their inventions were not successful. But they are still working on it for the future earthquakes. Some safety tips for people that need to know how to survive an earthquake is, if it happens, get under a strong table or desk that won't move and keep an emergency bag under a bed or something. And after the earthquake, check your family for injuries.
What causes a tornado is by warm and cold air mixes and makes a funnel cloud, and when the funnel cloud hits the ground, it's called a tornado. What destruction can a tornado cause? Good question. Tornadoes can cause a lot of damage depending on what kind of tornado it is. How a tornado is rated by a Vegeta scale. F number is F0, which fastest 1/4 miles per hour, 40 miles per hour to 72 miles per hour. 2-second gust miles per hour, 45 and 78. You just want me to pause it there?
Huh? Yeah, go ahead and pause.
Earth's plates rub against each other, they get stuck, they build up pressure. When all that pressure gets released, P waves and S waves go out and an earthquake is made. Most earthquakes can be felt. The ones that can be felt might be devastating because they destroy roads, buildings fall over. These are not that common though. Earthquakes are rated by how strong they are. Like this, for example, 6.5 or 1.7. That is how an earthquake is rated. Usually an earthquake will happen near fault lines. People living near these fault lines have a better chance of a big earthquake happening. The biggest deadliest earthquake to be recorded happened in the year 1960 in Japan. It was a 9.5. It also made a tsunami. 830,000 people died. It was also a horrific earthquake in San Francisco's houses were destroyed and people had to live in tents. Unlike other natural disasters, an earthquake cannot be predicted. It can only be assumed for when it's going to happen. You should never be outside during an earthquake. Also, make sure you live in a stable building. Do drills and make sure there's no loose wires. Don't be near things like a TV or face because they could fall and kill you.
Hurricanes. Hurricanes. My force of nature is hurricanes. They pack big gusts of wind and a lot of rain.
Every hurricane offers scientists a chance to learn more about how these storms work. August 2008. Hurricane Gustav is the third hurricane in 3 months to threaten the southeast. Now, 250 miles wide, with gusts of wind nearing 150 miles per hour, this monster storm is propelling itself through the Atlantic on its way to the U.S. Gulf Coast. And the Army Air Reserve hurricane hunters are heading straight into it. Major Brian Schroeder is the unit's weather officer. He's going to get them into the heart of Gustav.
To get really at what goes on inside the storm, we need to fly through these storms to collect the weather data.
They want to figure out how this hurricane is put together and what it's doing. Is it growing stronger? How fast are the winds? And the big question on everyone's mind, which way will it turn?
All of the forecast models have it hitting somewhere near New Orleans or slightly to the west of there. Of course, As time goes on and as this system moves into the Gulf of Mexico a little bit more, all of that could change.
Gustav is large, powerful, and hard to predict. It's like a gigantic machine with a lot of moving parts, all moving fast. But where does a monster storm like Gustav come from? The seeds of all hurricanes lie in gentler winds that constantly circle the Earth.
The wind is created by an unequal distribution of pressure on the surface of the Earth. Now, we tend to get low pressure where warm air is rising over the equator, high pressure over the poles where the cold air is sinking. And this air wants to flow from the area of high pressure towards the low pressure. This is what creates wind in the atmosphere.
So colder, high-pressure air rushes in from the poles to replace the warm, low-pressure air rising over the tropics. The winds collide near the equator, where they are forced straight up, drawing warm, moist air away from the surface and up into the atmosphere. This is the Intertropical Convergence Zone. This is where hurricane assembly begins.
It is a very unique location because it's very persistent. Now, 24 hours a day, 7 days a week, 365 days a year, there's always this belt of storminess around the equator.
Throughout the summer, towering thunderheads form here. Hurricane parts, just waiting for a power supply to kick them into action.
The ocean waters are very warm because they've been heated by the sun. Now, as the air that's in contact with this warm water acquires the heat, and then the warm air wants to rise upward, this is called convection. Keep in mind, this warm air also has a lot of water vapor in it. And as that air rises just a few thousand feet, it begins to cool off, and that leads to condensation. So that's why clouds are associated with this convection over the equator.
The converging winds and tropical sun produce conditions almost perfect for hurricane creation.
The Intertropical Convergence Zone provides a lot of the necessary ingredients to get a hurricane going. What we still need to get going is rotation.
In the Atlantic, the spin power comes from the hot winds blowing across Africa.
An African easterly wave is a belt of fast-moving wind that gains energy as it moves across the continent of Africa. If you allow this belt of wind to begin interacting with mountains or terrain features, sometimes the belt of wind can be disturbed, and it can form little ripples or little eddies.
Every few days, hot winds ripple off the African coast. They bump into the storm clouds sitting in the tropics and start the clouds spinning. Now, they begin to move and turn in a more organized band. If they get organized enough, they become a tropical depression. And that's how the hurricane building process starts.
Credits: Shepard, WizByTheKids.com, app.discoveryeducation.com. The destruction is rated by the Saffir-Simpson scale, which is a Category 1, 74 to 95 mile an hour winds. Category 2 is 96 to 110. Category 3 is 111 to 129. Category 4 is 130 to 156. And Category 5 is 157 or higher. The strongest hurricane ever had 95 mile an hour winds. Katrina and Ivan devastated the United States. Have sandbags in case of storm surge and evacuate off the beach if you have a beach house. Hurricanes is still one of the minds of meteorologists and hurricane experts. Thank you for your time. I did.
Tornadoes! How tornadoes form. When cooler and warmer air meet, which creates an updraft. The damage. An F1 does light damage, an F2 does minimal damage, an F3 is lots of damage, an F4 extreme damage, and F5 is incredible damage.
An F1 does light damage, an F2 is minimal damage, an F3 is lots of damage, an F4 extreme damage, and F5 is incredible damage. Where tornadoes happen. Tornadoes occur in Tornado Alley, but the big ones happen in Texas, Kansas, and Oklahoma.
What Causes Tornadoes? By Braden Hastings. The wind is cold on one side and warm on the other. The wind comes from different sides and creates tornadoes. What damage does tornadoes cause? Tornadoes cause broken homes, ruined cities, deaths, and lost people. What is the type of scale meteorologists use? The Fujita scale is what measures tornadoes from F1, F2, F3, F4, F5, and also sometimes F6. Where does a tornado form? Tornado Alley is where tornadoes are most at, like Kansas and Dallas. What are some places tornadoes form? Some major tornadoes like May 10th, 1905, Oklahoma, or May 21, 2013 at 2:30 p.m. A lot of homes were gone, people passed away and got lost. Can tornadoes be predicted? Tornadoes can't be predicted, but people do know, like on news, they say to watch or warn them.